Today we're going to talk more about these linear functions. A linear function is a function whose graph is a non-vertical line. So let's talk about that. Why is it not vertical? Well, if you think about it, all of our vertical lines have the exact same x value with different y values. And to be a function, you can't have the same input have more than one output. Well, if you picture the graph or the table for a vertical line goes straight up and down, that would fail the function. You can definitely graph it. We've seen vertical lines. So linear means that it's a nice perfect straight line. The only line that would not also be a function is the vertical line. So the definition includes non-vertical lines. All other lines, horizontals and all the diagonals, would be a linear function. A linear function can be written in the form that we've seen so much of this year, y equals mx plus b. So if I can see a graph or a table or some ordered pairs, and I can put it into y equals mx plus b, then I would know I have a linear function. So let's look at a few examples. So with a graph, this again goes back to chapter 4. So really nothing new here, just need to make sure we remember and recall what we have learned. So remember, slope is our m, rise over run, change in y over change in x. Then remember that the b is our y-intercept, where the line crosses the y-axis. So with those two things in mind, hopefully we can now move on to the graph and writing the function. When you see this little phrase here, relates y to x, basically that's saying y equals, and the x is on the other side. So don't get confused by that. That's just another fancy math way of saying y equals, and the x goes on the other side with the other numbers and operations. So, looking at our first one, well, I need to fill in a few things. I need to fill in the m and the b. So what is the m and the b? Well, if I look at my equation, right here is where I see it crossing the y-axis. That would be my y-intercept, or my b. So that means minus 3 is going to be at the end of my equation. Now, what is our slope? What is the m? So remember, you can pick any 2 points on this to figure this out. So I'm just going to start with 2, 0, and I'm going to go to 4, 3. So if I start with 2, 0 and I do my rise, 1, 2, 3, we go up 3. Then I'm going right 1, 2. Remember, up would be positive, right would be positive. My m is a 3 over 2. So then I just plug that in to my equation. And if I really want to make this definite, 3 over 2x minus 3. There is the linear function that's relating y's to x's of that graph. So looking at the second point. So again, we need to have those couple of things. I need y equals something x plus b. So again, if I focus on the y-intercept, it's right there. It's also negative, so it's going to be negative 1. And then when I look at my slope, I'll do the 2 points on the left side. I would come down 1, and down means negative, but I go forward 2. Forward means positive. So it's a negative 1 over 2. So again, negative 1 half x minus 1. There's the equation of that graph. Next, we want to talk about how we do it with a table. So like we did back in chapter 4, we could definitely graph this and use the graph to do all these things, but we also can think about this smart and help ourselves out. So the b, remember that's our y-intercept. And one thing that we know about all y-intercepts is that the x is a 0. So, looking at my 2 examples, I have that already. I have 0, 3 right there for my y-intercept. I have 0, 2 on the other one. So I'm not going to worry about trying to figure out what the y-intercept is, because that is telling me that's what it is. So the first one, let's just go with y equals, we don't know the m yet, but I know the y-intercept is a 3. So now I want to focus on that slope, rise over run. So looking at my x values, they're going up, +1, +1, +1. At the same time, my y's are changing by a -2 through each of those points. And remember, y's over x's. So change in y over change in x. -2 over 1. Don't fall into the trap of doing x over y, because the table is written this way. Change in y is the -2 over 1, which can reduce to -2. So there is the equation or function rule of that table. Now on the second one, so we have the y-intercept already. We'll start this with x plus 2. Now we need to find the slope. So these again are going up by 1s. So delta y over delta x, we're going up by 1s for the x's. And notice here, adding zeros. So 0 over 1. Well, 0 over 1 becomes 0. So I can leave it as 0x plus 2, but what does 0 times x give me? 0 times anything gives me 0. So really, this equation is going to look like this. And what do we remember about an equation that's y equals a number? It produces a horizontal line. So next we want to look at this word problem. The UAV is used for surveillance, an unmanned aerial vehicle, kind of like a drone. The table is showing the height in thousands of feet. We want to keep that in mind when we start looking at kind of talking about what this is telling us. And the x is the minutes after it begins to descend from cruising altitude. So first, write and graph the linear equation, that function that relates y's to x's. So again, we already just talked about the b is 0 comma something. So y equals, we know the 65. Now we just need to figure out the m. So paying attention to our numbers here. This time our x's are going up by 10, not going up by 1s. And at the same time, our y's are coming down by 5s. So then if you put the y over the x's, -5/10 becomes -1/2. So there's our function. Now we have to figure out how to graph that. So when you're graphing this, you want to think about this for a second. Because we have a word problem, we want to make sure we include our labels. So the other thing is, can we have negative minutes? Can we have negative height? When it gets back to the ground, it would be at 0 height, and we wouldn't be timing negative minutes. So we're only going to be focusing on quadrant 1. So I'm going to put my y-axis here and my x-axis over here. Now, what do they represent? So my x-axis is minutes right there. So I'm going to put minutes. And my y-axis is talking about the height. And I'm going to put right here 1,000. Because remember, the height is not really 65. It's 65,000 feet. Okay? So then we want to look at, well, what do our scales going to look like? Well, I have to get to 20 for the minutes, and I have to get to 65 for the y-axis. So I think on the minutes, I think if I went by twos, we'll make it. So I went by twos down there. And remember, I don't need the same one for my y's. So for the y's, I'm going to go by fives. I think. And I know it's not ideal, but I'm going to go 65 and pretty accurately, I think, give that same height. Just because real graph paper would have a little bit more space to make this work. But ideally, you shouldn't see that box there. So now I can just plot my points. So let me just change the color here. I use blue. So 0, 65 would be this one right here. 10, 60 would be right here. 20, 55 would be right here. So to write this graph, I would be connecting, and it would look something like that. Okay, so that's certainly a way you can do this. Now, obviously, if I went out a lot further, I might be able to see further on what's going to happen with when it lands. But for now, this is the best kind of zoomed in way. And you could have changed it or made it further out on the x-axis if you really wanted to see it go further that way. So from here, the last question says to interpret the slope and interpret the y-intercept. Now it's important that we remember what that means. Interpret. Big key word. Not that the slope is -1/2. Not that the y-intercept is 65. Interpret means what do those numbers mean? So more detail. So let's just do those. So the slope. So remember, slope is rise over run. So if you think about it, that in this case, the rise would be our height. The run is our minutes. So there's two labels when you're describing what slope means that you need to include. Okay? So our slope as numbers is -1/2. Okay? Now remember, that -1 really means down 1,000. So we can write this in two ways. So the slope, what does it mean? That means we descend or go down 1,000 feet every 2 minutes. Or if you look at that, I could even change that a little bit better. And couldn't I say that we descend 500 feet per minute? So the over 2 minutes is fine, but this is actually a better one. That tells us how fast we're descending or going down. So the slope is telling us that we're descending 500 feet a minute. So then what is the y-intercept telling us? Well, the y-intercept is 0 minutes and 65 for the height. What does that mean? What is that telling me? What that really tells me is that we were at 65,000 feet when we began the descent. So that 0 for minutes means now. Like when we started the descent, where were we? 65, but that really means 65,000. So the y-intercept means we were at 65,000 feet when we began the descent. So on the next one, last one here. So here we have the cost of buying X cubic yards of mulch from Company A, including a one-time shipping fee, is represented by this function right here. The table is showing the cost, including the one-time shipping fee of buying mulch from Company B. So Company B is this one. Okay, which company charges more? So that's something that's important to kind of look at, and how much more. So when I look at A, so here's my A company. They already gave us the equation right there. So Company A, money per cubic yard. Well, money per cubic yard, that's really going to be my y-intercept. So one-time fee would be the 30. Dollar per cubic yard would be my slope, or the 29. So it's $29 per cubic yard. So looking at the B, we don't know what that is. So what we have to figure out is, how do I find that? So if I look at this, 1 cubic yard is how much money? Well, if I look at my table for Company B, 1 cubic yard, it looks like it's $48.50. But remember, the table including a one-time shipping fee. So it's not $48.50. So it might seem like this is an easy answer, but that 1 cubic is including the amount per and the shipping charge. So what I really want to look at is the slope. So I need the slope to determine this answer. So again, change in y over change in x. Change in x's are plus 1s. Change in y's are what? These are going up by, I don't have a lot of room here. $33.50. So $33.50, and they go up each time. So that tells me my slope is $33.50 per cubic yard. So the question comes to, which one charges more? Well, Company A charges 29 per cubic yard. Company B charges 33 per cubic yard. So who charges more? Company B. And then also the question is, how much more? Charges $4.50. $1.50, which is a lot, per cubic yard more than A. So again, the first part, we already had the equation. We just need to understand those numbers. The 29 being the slope, which is the amount of money per cubic yard. So we didn't have to calculate anything. We just had to recognize which number we wanted. On the second one, it's important that you don't think that it's the 48.50, because you have to take into account that we actually, for one thing of mulch, we also have a service fee. So again, we need to find the slope. So we need to find the slope with our change in y over change in x. Now the last piece here, this is kind of a mistake. I'm not really sure why this problem doesn't belong to this. So I'm just going to kind of take this out. There's really nothing for you to do here. It's part of a different word problem that we used to use, whereas we've now switched to the one that we just went over. So that basically helps us understand how to write these equations and understand this word interprets a little bit better. If you have any kind of questions, please feel free to let me know the next time I see you in class.